trying to find where two lines cross requires a little bit of algebra. The first method we're going to use is the substitution method, where you just hook two equations together. But just the basic idea, right? If you have a Cartesian plane and you have a line coming this way and you have a line coming this way, they are going to cross somewhere. And at that particular place, that has a y coordinate and it has an x coordinate. And right there, the y values of this line and the y values of this line equal each other. So just to tell the lines apart, I'm going to put a little 1 there for line 1 and a 2 there for line 2. So the way you set this problem up is I want to find the place where this line and this line have matching y values. If I can do that, I will be able to deduce the place that they cross. So this whole exercise starts with, where is y1 matching y2? Get this mess out of the way. I don't have numbers for y1 and y2, but I do have equations. So I'm going to put this equation in for y1. And I'm going to put this equation in for line 2. Now, from previous courses, if you have x's on one side of the equation and x's on the other side of the equation, you need to get them together. So I'm going to get this over here by subtracting 3x from both sides. So 4x minus 3x is 1x. 3x minus 3x is gone. That was the point. Leaving just this 7 behind. Now I want this to say x equals a number. So this 5 is in the way. So I'm going to have to move it as well. Let's subtract 5 from both sides. That leaves me with 1x. I'm just going to write x. 5 minus 5 is gone. 7 minus 5 is 2. So the y value of this line matches the y value of this line when x is 2 in both of them. So I have the x coordinate of the point of intersection then. I just need the y coordinate. And I can get that by feeding this number to either this line or this line. I should end up with the same number. So I'm just going to pick that one because it comes first. If I put 2 in there, four times 2 is 8, and 8 plus 5 is 13. So my point of intersection is when x is 2 and y is 13. Now just in case you don't believe me, it's good to question. If I use this one instead, put my 2 in here, three times 2 is 6, and 6 plus 7 is 13. So I ended up with exactly the same number using the other equation, which should make sense because the whole idea of this at the beginning was find me an x where the y value matches in both equations. So that's a great way to check your work. If you get an x value and you put it in equation 1 and you get 13, you put it in equation 2 and you get 26, you know that something's wrong with this x value because these numbers, the y values of both lines have to match at that place. All right, so I'm just going to put this on a graph so you can sort of see how this is working. So we need a y-axis and then we need an x-axis. and I have line 1 starts at 5, and it goes up 4 over 1. So it looks like this. Oops, missed a little bit there. Whatever. And then I have line 2 that starts at 7. 1, 2, 3, 4, 5, 6, 7. And goes up 3 over 1. 1, 2, 3. 1, 2, 3. And look, they cross right there. They have a common point. And that common point happens to be at 1, 2 on the x, and 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13 on the y. So there's a second way that you can check your work. Take your 2 lines and sketch them, and they better cross at the place that you've indicated. I have another example of the same idea. I have a line here, and I have another line, and I want to find where those 2 things cross. So I need to find where the y value from line 1 and the y value from line 2 line up in exactly the same place. So I start by equating them, because that's what it means to be in the same place. I have an equation for line 1 to fill it in, and I have an equation for line 2 and fill it in. Now I just have to use some algebra to move stuff around. Well, I see x's in 2 places. I need them to be together. So if I add 4x to this side, and I add 4x to this side, I'd end up with 3x's, and 4x's is 7x's. And I have a 9 here that I haven't done anything with. Negative 4x plus 4x is gone. And that was the point. Now I want this to say x equals something, so this number's got to go. I'm going to add 5 to both sides. 9 plus 5 is 14. And I'll need to finish by dividing the 7 off of this x. So I'm left with x is 2. Just like in the last example, once I get an x value, I just have to feed it into one or the other of those equations. I'm just going to choose this one. So negative 5 plus 3 times 2. 3 times 2 is 6. And negative 5 plus 6 is 1. So my point of intersection is at 2 on the x, 1 on the y. So I'm just going to graph it to check. I need myself a y-axis and an x-axis. Line 1 starts at negative 5. 1, 2, 3, 4, 5. And it goes up 3 over 1. 1, 2, 3, and 1. 1, 2, 3, and 1. 2, 3, and 1. Right. Something like that. And I have line 2 starting at 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's check that. And it drops 4 every x step you take. 1, 2, 3, 4. 1, 2, 3, 4. There it is. 1, 2, 3, 4. There's line 2. And you can see that those two lines come together when the x value is 2 and the y value is 1. The y equals b plus mx form is usually full of fractions, so we should probably do one that has some fractions in it. So I'm going to just hook these two together like we've been doing before, because the fractions are just numbers, so they aren't going to change the method. So y1 has to match y2, which means that 11/3 plus 2/3 of x has to equal 8/5 minus 7/5 of x. There's a lot of fractions there. The next thing we should do is add this over there. But if I do that, I'm going to have to know how to add 2/3 to 7/5, and I'm not sure I want to do that. So I'm just going to scale up these equations to eliminate those denominators. I'm going to look at this side first, and I'm going to see divisions by 3. I don't want them there. You can get rid of a division by 3 if you multiply by 3. So I'm going to do that. 3 times 11 would be 33, divided by 3 gives you 11. So that denominator has been eliminated. 3 times 2 is 6, divided by 3 is 2. So that denominator has been eliminated. Now over on this side, I've got 3 times 8, which is 24. And that denominator is still around because 24 doesn't divide evenly by 5. 3 times 7 is 21. And that denominator is still around because 21 doesn't divide evenly by 5. So I maybe made a bit more of a mess on this side, but I cleaned up the fractions over there. Now, if this method worked to eliminate divide by 3 over here, I can use it to eliminate divide by 5 over here. I'm going to take this whole line and I'm going to multiply it by 5. So 5 times 11 would be 55. 5 times 2 is 10x's. 5 times 24 is 120, and then 120 divided by 5 is 24. So that denominator has been eliminated. 5 times 21 is 105, divided by 5 gives you back 21. So that denominator has been eliminated as well. And now I have a line here. It has some bigger numbers than what I started with, but the fractions have been eradicated, which I think deserves a smiley face in most people's opinions. So now I just have to get the x's together. So I have to bring this over here by adding 21 x's. It gives me 55 plus 31x. It's 24, and these two things undid each other, which was the point. I want this to say 31x equals, so I need this to be gone, so I'm going to send it to the other side. So that leaves me with 31x over here, and 24 subtract 55 is negative 31. So to finish, I just need to divide out the 31 on both sides. So x is negative 1. Now, once I have an x, I just fill it into an equation. So I'm going to choose this one. Y equals 11/3 plus 2/3 times negative 1. Well, that's 11/3 minus 2/3, which gives you 11 of them minus 2 of them is 9 of them, and 9/3 is just 3. So these two particular lines come together. The point of intersection is at negative 1, comma 3.